Hi and welcome to Unit 2, Topic 3, Video 19. In this video we're going to take our reflection over the line, the x-axis, y-axis, y equals x, a little bit further and talk about what happens if we reflect over the line y equals mx. So this time we want our image, x dash y dash, to be equal to a transformation here multiplied by the original xy. So here's the interesting thing. We get this result, and again, this is on the formula sheet, along with the dilation and with the rotation by an angle theta in anti-clockwise direction, so it's important to note. Now, in this case though, theta is not so obvious. We're rotating by 60 degrees, theta is given to us. Reflection over line y equals mx, theta is not given to us. Theta is the angle that the line y equals mx makes with the x-axis. So we need to work out that angle. And the way we work out that angle is to recognise, and I'll do this in blue, that if I drop this down here, I have some arbitrary coordinate up here, which is x, y, and I've got rise, which is y, and run, which is x, and tan theta is equal to y over x, opposite over adjacent. So tan theta, y over x is rise over run. That means that tan theta is equal to the gradient, m. So if we want to know the angle, we just do tan inverse of the gradient. And I've written this over here. Note that theta is tan inverse of y over x, but we can do that just with the gradient. So that's really nice. To get theta, we do tan inverse of the gradient, and it will give us our theta value. So then we put that into here, cos 2 theta, sin 2 theta, sin 2 theta, negative cos 2 theta, and we'll get our transformation matrix. Again, this is explained with a really good breakdown of how this is proven in a textbook, but I'm not going there yet because it does rely on double angle formula stuff from topic 2, which you may or may not have done from unit 2. So let's have a look at an example. In example 5, by what matrix would you multiply 0.23 in order to reflect it across the line y equals 3x. Does the same rule apply for y equals negative 3x? So just keep in mind that y equals 3x to y equals negative 3x is there and there. And you've got to guess that the same rule doesn't apply, don't you? It might be a similar rule, but it won't be the same rule because obviously we're not going to get the same result by reflecting across two different lines. So the matrix we multiply by is the transformational matrix, this one here, which I can't remember, cos, so they get negative cos there. So it's cos of 2 theta, sine of 2 theta, sine of 2 theta, negative cos of 2 theta, where theta is equal to tan inverse of m, which in this case is tan inverse of 3. Now, I could muck around trying to find tan inverse of 3, and it's about, so it's rounded, about 1.25, and it'd be worth keeping our value. But there's some tricky stuff you could do here as well, involving, maybe drawing this triangle here and considering, can I do something clever where if this is my theta, then that's 3 and 1, tan of theta equals 3 over 1, it could be 6 or 2 or whatever. We get a hypotenuse of 10, and we can work out cos and sine of theta as well, 1 over root 10 and 3 over root 10, and we can use that in a double angle formula. But again, we haven't gone through that double angle formula, so I'm going to have to use my calculator to find an approximate value, 1.25, but I won't have a problem here, asterisk, as long as I keep my answer in my calculator. So let's run through what I get. My transformational matrix is equal to cos of about 2.5, sine of about 2.5, I've kept this answer in my calculator, sine of about 2.5, and then cos of about 2.5, but the last one is negative. And when I put that in my calculator, I get this, which is really interesting. Negative 0.8, 0.6, 0.6, and 0.8. My transformational matrix is exactly those values. So you can see it comes because of this. I can be clever about this, but you need some knowledge from Unit 2, Topic 2, before you can be clever about it. Okay, so there's the result. If I wanted to find my image, P dash would be equal to negative 0.8, 0.6, 0.6, 0.8, and that would be equal, that would multiply by 2 3, and the result would come out to be 0.2, 3.6. And if you go through now just to answer this question and do tan inverse of -3, I believe you'll get something like -1.25, although off the top of my head I might be wrong. And so you won't get the same result because cos and sines will be different for that value. You get a similar transformation matrix, but it won't be the same. Okay, and then we have an extension here related to exercise 18G again. How would you reflect the shape of the line y equals 3x plus 1 with a plus c value? And we'll talk about that a little bit later again. So that's the end of the video. All the best.